All right, we're now going to go through an example of using the minimum cut method, and we're using example 1 from above. So remember, this is the one that we answered simply by using inspection. So if I was to ask you to find the maximum flow of this, what you would do is just consider the smallest weightings. So that would be 4, 3, and 5. When you add all these up, it's going to be 12. So that means the maximum flow from source to sink is going to be 12. But we're now going to use our minimum cut method. So what do? Well, when using the minimum cut method, the first thing that you want to do is isolate the source and then isolate the sink. So we're going to make 2 initial cuts. So as you can see here, I'm first going to isolate the source. So remember, and I'll just look at this example here. This is my source. Oh, that's ugly. Let's try that again. This is my source. This is my sink. So you want to begin by isolating your source. So when I do that, I'm going to end up cutting this part right here, which is going to be 8 plus 3 plus 7. And that's what we can see here for cut 1. The capacity of cut 1 is 8 plus 3 plus 7, which is 18. So meaning if I was to make a cut here, it's going to cut it and have a capacity of 18. If I was to isolate the sink, so this is the second cut I'm making, this is going to give me a capacity of 4 plus 3 plus 5 is 12. So if I was to cut it there, it's going to give me a capacity of 12. Now, once you've made this, so this is the first thing that you do when you're using the minimum cut method, you isolate the source, then you isolate the sink, and you figure out the capacity of each of these cuts. Now, the smallest of these 2 cuts becomes the base value or the number to beat. So now 12 is smaller, so 12 becomes the number to beat. Can I make another cut through this network, which is going to give me a number smaller than 12, so number to beat? So let me just repeat that. The first thing that you do when you get one of these problems is you isolate the source, so give a cut to the source, give a cut to the sink, figure out which of these is smaller, and then you're going to think to yourself, all right, the smaller number is the number to beat. All right. Then cut through each of the paths, aiming to cut the smallest edges and end up with the smallest capacity of the valid cut. So for instance, now that we've done cut 1 and we've done cut 2, now you want to say, all right, can I cut this another way that beats 12? So you might say, all right, what if I went 4, 3, and 7? Well, if I do that, I end up with 14. But 14 is not smaller than 12. So the minimum cut is C2 with the value of 12. Therefore, the maximum flow is 12. So notice that we weren't able to make another cut with a smaller value than cut 2. So that means that our maximum flow is going to be 12. Can you see another cut that would yield a smaller capacity? And you should say no, there is no way of doing that. That means this cut right here, this one right here, is my minimum cut. Minimum cut. All right, hopefully that made sense. And again, the examples are going to get a lot more hairy, so don't think that this is as hard as it gets here. And we'll see some more hairy examples soon.